Hello friends, this is Sandeep here. Thank you. First of all, I would like to thank you for giving such a overwhelming response to our COVID-19 activities of solving one of the live project. So there are so many candidates actually who have enrolled their name actually for this particular activity of solving the live project. It is a commercial building in Bangalore, which so many thousands of students who have enrolled to our company, they have joined it. They have registered their names and all actually as a mock interview, and this is extension activity for that. So when you register your name to our email, actually, we will be sending you one link in which you will see these files actually. Okay, so architectural plan, structural plan, center line plan, and a problem statement. So once you download it from here, actually, what will happen is, let's say this is the file which once you download it, you will see that there is a RAR file. This file actually need to unrar it actually or unzip it, and then you will get the folders. So in these folders actually, what you will see, first one is actually the architectural plan. This is the DWG file, you will get it. Okay, then second thing will be the structural plan. Then you will get the center line plan, which we are going to import it from the CAD to etabs. There will be the problem statement. So let's see one by one what is it. So let's say we'll go to the problem statement first. So problem statement, you will see that this is G+4 building, this is the floor to floor height, and these are preliminary sizes of the beams and columns. So this can be varied. So let's say 600 by 600 beam. I don't want to have it. You can easily reduce it. Okay, so but initially you require something actually to feed in. So these are the sizes of the beams and columns and all actually. So um, what is the problem? Problem is basically you need to design all these columns, beams, and slabs, particularly the superstructure in the ETABs. There are so many students and people, they say that, sir, I wanted to go for as a project manager, I want to go for as a site engineer. So, why we have to go with the structural first? So let me tell you very honestly that even if you are a site engineer, when you go to the site, what thing starts first? The structure. Okay, excavation, PCC, or column foundation. The structural activity, it begins at the first. Okay, so it is very important for a site engineer or a project manager or BIM modeler to understand the structural requirement. So in our course also we generally start with the structural because that's a core thing. Then after you finish the first skeleton, then the electrical, plumbing, the interiors and all actually exteriors, that will start. But the first thing, it will start with the structure. So we begin with, as you go to the site, what starts first actually. So how to start with this kind of problem statement actually, let's get started. So I have downloaded all these files to my folder actually. Let me, 1 minute. Yeah, so this is the folder. One more thing actually I wanted to tell you, that centerline plan is also there in the DWG format, which you need to change it to the DXF format sometimes. So some of you were wondering that, sir, I don't have the AutoCAD with me and all actually. So don't worry, you can go to the Google and you can just type DWG to DXF converter. If you just go to any of this website actually, you can select the file from here. So let's say for example I wanted to select one file, and now I'll just I'll select one file. So let's say this is a centerline file. I'll select it, and I would like to convert this file to DWG to DXF. Alright, so once you do that actually, so let's say this is the file format. I'll do it again. DWG to CAD to DXF. Okay, so convert to DXF. So once you do that, actually just say convert file. So it will be converting it, it will upload it, it will convert it. Okay, and it will download also. So please, you need to click this DWG to DXF. Now I'm just downloading this file. So this is the downloadable file. So once you download, actually you can, I'm just pasting it to a particular folder. So let's say this is our folder in which in the center line only I'll just paste it. So you are having DWG file also, and you will be having the DXF file also. Now this file I wanted to import it. Now this is just the conversion. Actually you can do it in the AutoCAD file also, and those who are not having the CAD installed, I have just told you that how you can quickly do it. Now to begin with, actually I'll start working with the eTabs. So double click on the eTabs icon. I'm using 2016 version actually. So from here you can go to the file, new model, and you can go to the file initialization. So you can just select this SI units and all, actually just say okay. You can go to the blank option. You can also go through the grids only, and you can give the grids actually. That I think I have already explained you in the mock interview, that kind of sessions and all. Actually after mock interview sessions we were having the problem solving statement. So during that time I have explained you this. Today I'm going to explain you how to import from the CAD to the eTabs. So you have to go to the blank option. So you will see that two windows with the blank options are coming here. Nothing is there. Okay, so you need to import the file. Now how to import it? You go to the file, import, and this is the command for you, which is DXF file or floor plan. Alright, so once you do that, you require the DXF file. So where is that file? So that file will be in the centerline plan. As you know that we have just imported this file. Alright, so from here you need to give the basic unit. So currently the unit is in meters, and from here you will give that as a center line. Alright, so these are the basically the layers in the CAD file that you have chosen, and just say okay here. And you will be saving this file by creating the folder. Let's say I'll create the assignment folder, and I'll just superimpose this file on this. So you will see that the assignment is there right in front of you guys. So just close down the 3D view and just select only on the 2D view actually, because you need to deal with the 2D systems only. Alright, to begin with, we will just cross check it whether it is imported properly. So it is 8.81 meters and all. So if you import that in mm, it will be 8 mm. So please make sure that you will be importing it properly. Alright, right. So from here actually I will just select and check all the membrane and all the elements, it is correct or not. So deliberately we have done certain mistakes in this because many of the complex CAD files will have certain mistakes actually. So let's see that. So you can see that B1 is there, which is B1, beam B1, and another beam is B4, like totally it is one beam. So we don't want that total beam as one beam. I want B1, B2, B3, three numbers are there. So how to edit it? You can just select this and go to, and like this I'll select this also, because I can see that there are some issues at this place as well. So I can go to the, or maybe this I'll show you it in another way, because there is a different kind of mistake here. From here you go to the edit, divide frames. I'll divide frames from here. So you can see that the one beam is divided into three parts, 1, 2, 3. That's what we wanted, because there are columns coming here. Okay, some of you might be wondering what sir is doing and all. So I mean, before you do that, I'll just explain you the CAD files actually. So I'll just go back to the CAD files so that you will understand what I'm doing. So from here actually I'll just double click on this CAD. So the CAD true viewer, it will be there here. Some people will be saying, sir, I do not have this software and all. You can easily download this software actually from the internet. It is free of cost. It is viewer. It is not the CAD actually that you can do the CAD thing in this. Actually, you are just going to be viewer. Right, I'll just say. Right, so in this is the file. You can see that this is the architectural file. This is the basement. So you can see that there is a half basement here, and there is a showroom here, and the one staircase which is going from ground to the basement. And there are some toilet blocks and generator rooms here, and there are some shops out here which is at the ground floor, and this is the typical floor. Alright, so this is the architectural plan that you guys are having. Then you will see the structural framing plan as well. I'll just show you that also. So this is the structural framing plan. So these are the 4 columns. I'll show you both the options, actually how to deal with the columns and also through the shear wall. Some people they use the shear wall also. Or if you want to do it, you can deal with the 4 columns also. Like these are the columns here, these are the beams, and there will be the slab and all actually. So this is a typical floor plan that I just wanted you to view. Now the third one is the center line plan. Now center line plan, this plan I'll just open it. So this is the center line plan which we have imported it. Alright, so you can see that there are few mistakes actually. You cannot able to see the mistake here, but you can easily spot out those mistakes once you import it. Now how do we do that? Now here this is one mistake which I have told you. Another mistake is like if you click here, you will see that the beam is up to here, and this beam is from here to here. So I just don't want to have the beam from here to here. I would like to have now this is a reshape command in which you can just drag it and place it at the appropriate location. And this is one more beam. This is another beam here, and this is another small beam here, which is not required. So I'll just click both the two, and I'll merge this. So from here you can go to the join the frames. So you can see that this is joined. Similarly, I would like to join these 2 beams also. There's 1 and 2 beams. So you can go to the edit frames and join frames. Alright. Now in this case, let's say there is another also command. If it is not working, you can just click it here, and you can see that what's really happening. So you can see another beam is created, which you need to delete it, and then click this and put it at the right place. So this is the reshape command. Reshape command is actually you can, now in this case also you can see that there are unwanted these dots or the joints are created. Now we need to really work upon it, how to get rid of this. So first of all, I would like to join this line to here. So I'll select this line as well as I'll select this line, and I'll select this joint also. You go to the edit, then you go to this align option, and you can just extend these beams. So you can see that this has got extended. Similarly here also you can select this line, you can select this line, and you need to select this point also to extend this. Alright, so once it is done, actually you can just see that actually how it is working. Now this is not correct, so this has to be here, and this is also not correct, this has to be over here. So you can see that I'm trying to correct this model. Many times this needs a little bit sense about the drafting also, while you need to educate your draftsmen also for correcting this in appropriate format. So I hope you got this, actually how to correct this. You can pause. I'm going a little fast, I know that, actually, because I need to give the entire information, but you can pause the videos and please go step by step, so that you will understand this. And first you can entirely see the video, and then while working on your laptop, actually I would like to encourage each one of you to solve at least once this particular project that will help you out in your career. that you go step by step and do this project, right? One more thing I wanted to tell you, that many people have not registered and they didn't get these files. Actually, if you don't get this file, I would like to show you. In that case, you can just write down this email address, info@e-construct.in. You can write to us on this email address. Actually, our staff people will revert to you. Okay, only for registration. If you want to do that, actually you can just write an email that please help us to register. All right, info@e-construct.in. Now, next one is actually we need to add certain columns and beams. So how do you do that? You go to the file. First of all, you need to create a material. So I'll create a material from here. You go to the India concrete. Let's say I want to go for M25 grade of concrete. Just say okay here, okay here. Okay, one more grade. We need to create the steel also, because it is reinforced concrete. So do you want to go for steel? No, you will go to the rebar, because steel is basically the mild steel. So you will go to the HYSD 500, which is readily available. Then you can double click on this beam actually, and you can create the beam B. Let's say 600 by 600 is the problem statement, so let's go with that only. It might not be needed. So let's say I go to the 600 here and 600 here. Alright, so you'll view the depth and width as 600, and then you can click this beautiful option here, which is reinforcement. By default it will come as a beam. Sometimes if it is as a column, please select that as a beam. From here you will go to the HYSD 500. So this is the cover and all. Actually this is centroidal cover, so you please keep it same. Now you can double click on the column. Now I'd like to give the columns as same size, 600 by 600. Somebody will say that, sir, why 600 by 600? You can start with 300 by 300 also, nothing wrong in it, but you will end up with so many different iterations. All right, so initially you give this column size and beam size at this moment, and later on you can correct it. Now you go from here, the same option. Previously it was a beam, now it will be a column. Here also will specify this. All right, since it's a rectangular or the square column, actually will give the same rebars here and here. So you will see that 5 rebars at both the cases. So I have defined the steel grade, concrete grade, beam and column. Similarly, I would like to define the slab also. I'll go to the S200 M25. Okay, first it will be the thin shell element. Now I would like to add a copy of this ST200 M25. So I'll give that as a membrane. So membrane slabs, and I'll select this as a one way because this is the staircase. ST means for the staircase. Alright. So once you do that, actually just say okay here. So slab is defined. Now similarly we'll go to the walls option also. I'll define W. Let's say in the problem statement I think we are given it as 200 M25, and go to this one and give 200. Right, so all these are thin shell elements actually. Then once you do that, the definition is over. After define menu, you go to the draw menu. Now we need to start drawing the columns. Initially, let's say the beams are there. So let's say this is the beam. You just right click and check which beam is there. If it is different, just select all the beams and just drag and drop it here. So you can see all the beams are 600 by 600 M25. Alright, so beam is over. Now we'll go to the columns. Now columns, can you see this beautiful option here? This is quick draw columns. Now in this, actually you'll select the columns here, and you can select all the columns like this at these 4 locations at the extreme right and left for each bay. So totally there are 8 columns here, and there are some 4 columns are here. But initially I would like to give that as a shear walls, just to give you a different feeling. Alright, so this is the shear wall. Okay, so you can mark this as a shear wall, or maybe this is the column. You can mark that as a column. For column, actually, if you really want to mark that as a column, you can go, this one is, let's say, 600, and this one is, let's say, 200. This is C 200 by 600 M25. Or from here you can go to, let's say, 2 and 5. So this is 2 and this is 5, and this column actually you can draw it over here. So 1, 2, 3 and 4. So either option you can do it actually. Okay, either you can mark that as a column, or you can mark that as a shear wall. So initially I will mark that as a shear wall only. So I'd like to give that as a peer label as yes. This is required for the designing of the shear walls. Alright, I'll delete these beams, because wherever the shear walls are coming, actually the beams won't come. Alright, so once it is drawn, actually then we can start marking the slab. Now let's say we'll go to the marking the slab of this. So this is one slab, another slab, third slab. Now we'll go to the staircase slab. Oops, you need to basically drag it from this to this. It is not click here and click here, okay? It is a drag. It is not click here and click. It is always drag like this, okay? Alright, now there is one more slab here, but the rotation is 90 degrees. So I'll just change it to 90 degree, and I'll just draw one slab here. So this slab is resting here, this slab is resting here, but you need to have a beam here. So let's say I'll add a beam. From here to here, and from here to here. Alright, so this is the beam. Alright, so once it is done, actually the marking of the slabs and beams and all, we'll just give some beams as a release option. So we'll select these beams, and we'll give the release. Okay, so this release we have done. This is not correct. See, release means actually the bending moment will be 0 at that end. So do you think that the bending moment will be 0 here? Yes. But do you think that the bending moment, top bending moment will be 0 here? Answer is no. So you will select this actually, and hide this, so that you will have the release option here. Alright, so we have finished the releasing, we have finished with the modeling of the columns, beams and slab as well. Now we'll go to the loads. Alright, so first of all, let's formulate the gravity loads. We'll just look at the problem statement also. So this is the column, this is the beam marking, material also, the definition. So the dead load is how much? 2 kilonewton per meter square, and live load will be the 4 kilonewton per meter square, because it's a commercial thing. So let's get started. From here we'll define this, add this as a dead load as 2, live load as 4. So you go here, dead load as 2, live load as 4. This is the kilonewton per meter square. Right? So this is the load, that is definition at the normal cases. For staircase it is slightly different. Alright. So the pattern is different. So let's get started. How to define the different patterns. So this is basically, we'll just name it as general. But this is the name of the pattern. Give a sensible name. Don't give any um, raw name. So here we will give dead load as 3, live load as 3, which is staircase. Alright. One more type of loading is there. You can see that there is a OHT, water tank, and the lift machine room. So we'll give this 15 kilonewton because we don't know exactly the lift machine room also. So we'll give 15 and we'll give 0.75. So we'll add a copy of this. Dead load is equal to 15 and live load is equal to 0.75, which is inaccessible roof as per the IS 875 part 2. So let's say this is dead load as 15 and live load as 0.75. Right? How come 15? Actually 15 and all we need to actually calculate based on the equipment load and machinery load for the LMR, lift machine room, and also the water load and all. Actually we actually need to calculate this. Right, so once it is defined, actually we'll select all the objects of, let's say, the floors, and then we'll apply the loads. From here we'll go to the assign. This is the shell loads and uniform sets, and you can give this as a general load everywhere. Now in this case there is a staircase. Actually I just wanted to show you as well. See, this is the general loading, and this one will be the loading for the staircase. So that's what actually we are trying to define, the specific load of the staircase over here. Right, so this is finished. Now we'll go to the loading of the walls. So let's say go to the wall, select object type as beams. How to go here? I have selected only the beams. You have to go to the select and object type. Okay, so once you do that, you go here. But let's say I don't want to give the loading here, so I have deselected this, and then I'll go to the assignment of the wall load. How to assign the wall load? Go to the assign frame loads and distributed. Now from here, wall load is 0.3 is the width of the wall. We'll give the density as 10 multiplied by floor to floor height is 3.67 minus 0.6. What is 0.6? 0.6 is the beam depth. Again I'll repeat, 0.3 is the depth actually. Which is the depth or the width? See here, internal and external wall thickness is 300, so it is 0.3. Alright, so it is 0.3. Let's say I'll recalculate it for you. Star is the multiplication, into bracket 10 is the density of the lightweight block work. Alright, multiplied by into bracket 3.67 is the floor to floor height minus 0.6, which will be the depth of the beam. So this is the depth of the beam, because the wall will not go above the depth of the beam, right? So that's how it is. So this is the loading of the wall. Right, so once it is done, actually the entire loading and all, everything is finished. Now you can copy this to other floors because all the things have finished. So we need to see the floor arrangement actually for that. So let's see that. So currently 1, 2, 3, 4 floors are there, but we do not have it. We are having G+4 and OHT. So let's say this is ground, this is 1, this is 2, this is 3. We do not have the terrace floor, so we have to add the terrace and OHT also. So it is G+4 plus terrace, OHT. This is 4th floor, so the ground floor, 1st floor, 2nd floor, 3rd floor, 4th floor. This is terrace floor, and we also need to have a OHT. OST. OST is the overhead tank and lift machine room. Alright. And everywhere the floor to floor height is 3.67. Right. You can actually do that in Excel and copy and paste it here also, but it's easy to do it here only. Right, so once it is done, I'll just say okay here and okay here. Oops, where it has gone? Something is wrong? No, don't get scared. Go to the 3D. Now this particular floor is which floor? This floor is floor 3. Alright, so you need to copy. So you go to the edit and replicate. You go to the story. You can radial copy, you can replica through the story. You select all the floors except the story 3 because this data is there in the story 3 and base also. Please don't select the base and story 3. Can you see that? Everything got copied. Right? Now you go to the OST floor. Now this is which floor actually? It is OST. Can you see that spot out here? OST, yeah. So in the overhead tank actually, please make sure that in the overhead tank you need to, I'll just hide the default settings so that it is a little bit more easier for you to understand. Okay, I'll just save this file. Right, at the OST floor we do not need these areas, so I'll just delete it. And above the OST staircase is also not needed. This beam also may not be needed. But this slab actually you need to have it from here and again from here. Right, so if you right click, you will see that the loading is also not correct. So load, you need to give it back. You go to the assign, shell loads and uniform load sets. And here actually this is the OST load. So overhead tank load will be comparatively quite higher. So obviously, you need to see that. Right. So once it is given actually, then you can go back to the model and just save this. Now supports, you can just right click this supports. You can say that UX, UI, UZ is a restraint. So you can see that only the 3, it means it is a hinge support. So generally in the concrete area we will be giving the fixed support. So we'll go here in the base. So how to go to the base, again I'll show you. Go to the plan view and base, just say okay. We'll come here and then select all the base and go to the assign, joints and restraints. So you give the fixed support. Okay, by default it is pin support, it is a fixed support. Now just say okay. Now you right click and you can see that all the 6 degrees of restraint will be done. So now you go to the 3D, you will see that actually it is all the restraints are done. Alright, so once it is done, then you can if you want to give, you can give the loads which are earthquake loads. Now how to give the earthquake loads? You go to the mass source, define the mass source, unclick the first 2, click the last 2, give the dead load as 1, live load we will give that as a 0.5 because most of the live load is more than 3. Okay, you need to see the code for why we are giving these options and all. So this is the mass source, then you go to the define and give the load patterns. And the load pattern you give EX, and from here you select the earthquake, and from here you select the IS1893. Similarly you go to the EY and you can select this. So these both earthquakes we have defined. Now from here we will select only the X component and you will go to the zone, which is, let's say, Bengaluru, so 0.1, soil type is 2, and R value will give this as 3 because it is less earthquake prone. Okay, OMRF or ordinary moment resisting frames and all. and from here you will be defining the time period. Now time period is 0.09 h upon root d. Now we need to actually calculate it, right? So let's say give 1 time seconds actually and calculate it properly, and then give the figures. So this is also 1.1 and this is, let's say, 3. We need to calculate this, right? So let's get started. How do we calculate? First of all, you need to take the height. What is the height? 22.02, right? And then you need to calculate the width and all. So let's say you go to the dimension lines, and from here also you'll take the dimension lines. Okay. So how do we calculate it actually? I would like to show you in the let's say notepad. Okay, let's say time in x direction is equal to 0.09 multiplied by h divided by square root of dx. Alright, so how it is, this is equal to 0.09 multiplied by h is equal to 22.02. Where it is, see here. Alright, divided by sqrt square root of dx. Dx is this one. Whenever the force you are applying in this direction, this is your dx. So 8.8144. Right. Similarly, I'll just type down for ty is equal to 0.09. Height will remain same, as you know, 0.2 divided by sqrt of dy. Dy is this one, right? So 16.239, right? Now we will take a calculator from here to just calculate. So let's say 8.8144. Square root of that is 2.96. Okay, this 2.97 for example. So 0.09 multiplied by 22.02 divided by what was it, 8.8144 root of that equal to 0.6675, right? 0.6675 seconds. And similarly this also we need to calculate it. So let's say 0.09 okay multiplied by 22.02 divided by into bracket 16.239 root of that equal to 0.4917 seconds, right? So this is the figure. I'm just copying this figure back to etabs. Go back to the define, load patterns, and just go here, just paste it, just go here, and what is the figure? 0.4917 seconds, right? So here you will make sure that you will be defining only y, and here you will make sure that you will defining only x. So this is infield wall because 300 walls it is given in the problem statement to give it to everywhere. Alright, so once it is said, actually just say okay, and just on the OHT level, actually, if you know, in the OHT level, the loads will not come. So if you go here, you need to just delete it, and you can now go to the 3D, and you can see that on the roof, I mean, it will come on the roof, but it will not be there on the OHT. On the roof also, we'll give just 1 meter. So just select all this, and just go to the, let's say, distributed. Here you will delete this, all the loads, and we'll give only the parapet wall loads. Alright, so here it will be, let's say 10 is the density multiplied by 0.3 is the width multiplied by 1 meter. Let's say we take 1.2 meter, because parapet wall, but just 1 meter will not be enough sometimes. So 1.2 meter is the height. Actually that one we will give it here, right? So it's a parapet, and you will not have any wall here. But you will have a wall at this portion, full wall, and you will have the wall only up to here, from this point to this point. So how do you do that? So you go here again and go to, so this will be divided by 1.2 multiplied by 3.67. I hope how you are getting how I am calculating, because the height floor to floor height is 3.67. Now I need to take it, the wall load only up to here, so I need to divide it. I'll divide these frames, then I'll give the same wall load, and again, since the beam is same, I'll just join these two beams back. Alright, so once you go to 3D, you will see that the wall load is only up to here. This is parapet wall load, whereas this is the full wall load. Yeah, one more point is, actually at the back of this also there will be the full wall load will come, because we will be entering inside the terrace. Alright, so neatly, once you sensibly calculate that how to give this load, once you do that, actually just save this and run the analysis now. Now after running the analysis, you can see various different types of shapes and deflection shapes and all. Actually you can see this here. Alright, you can do the little bit dense meshing. Actually I would like to show you how do you do that. You can go here and go for the wall meshing, and you can give this as, let's say, 500 is the mesh size. That's the default I want to give. Okay, so I need to select the slabs for that. Do not select the staircase slab, only select the slab. Alright, so after you do that, I can select all the walls, which are shear walls, and then from here you can just mesh it up, the walls also. Let's say this is 0.5. Right, then you run the analysis. Now you will get a quite precise results. You will get. If you do any mistake, actually it won't come properly. Yeah, So you can see that actually the meshing is done, and this is a little bit more precise results than before. One more I think point I guess that is missing is I have unfortunately deleted this slab, or it's not coming properly. So let's see that what's the mistake. And I would like to add the joint labels also. This is a mistake. See? Alright, so how do you tackle this? You go to the all floors and correct it from incorrect location to the corrected location. Yeah, this is basically the rectangular shape issue. This may not be there in perfectly in straight line. So I would like to draw another line which is from here to the perpendicular. I'll just delete these lines from all the floors. And I'll go to edit, draw snap options, and go to the perpendicular mark. And from here I'd like to give the perpendicular shape. Now this is how it is. Now once it is done, actually then you need to draw this exactly at the center of this. Now how do we draw that? So select this and draw it at the perpendicular. Snap option will be the perpendicular. Similarly here also perpendicular. Till the perpendicular comes, do not click the left hand click button. Now this is difference between the how the plans are getting done by the CAD draftsmen. If they do the mistake, you need to pay the price. Alright, so I'll deselect from here the beams and delete the walls, and then I will again redraw the walls from here to here, from here to here. Once the wall is drawn, then you can delete the beams also. Right, now you can check that whether it is coming properly, because this wall was getting discontinued. Now in this case I would like to delete this wall from all the floors, and I would like to create the walls the slab one more time from here to here. Yeah, so from this point now this is basically the wall issue. Just a minute, this one actually I would like to delete. And redraw this to the perpendicular. And then draw the ST slab. Right. Right, so everything actually this issue, now this is also not coming properly because probably this is not a rectangular. So I'll just go back to this portion and I'll select one by one. right? And then you can just simply run the analysis. Yeah, so you can see that previously this slab was not coming properly, now it is coming. In your case, do not dealt with all these issues. Maybe you can redraw it with the this option. I'll again show you. Instead of correcting all these things, actually just delete this and redraw it with this option, this one, right? So instead of selecting from here to here, because this is not exactly, this is only 1 or 2 difference also, if it is coming, actually it will not come properly. So you select with this option 1 2 3 4 like that, actually then it would work. Okay, it's a small drafting error. If the 1 or 2 also, if there is a difference between both the points, actually between this is not coming exactly in the center, then these issues will pop up. Alright guys, so we'll again go back to the how it is working with the other floors, because we have edited the other floors also. So we'll just delete those floor slabs and all, and we'll go to the ground floor also. This also will delete. Make sure that you apply the single floor and all floors properly from here. Right, so then run the analysis. Now you will see that the warning previously it was showing, it will not show, and it will show the proper deflection shapes. Alright, now we'll come to the design part. Now we'll go here and add a design, actually the concrete frame design. So these are the combinations. Now you go to the design, then concrete design. You can, by default all the load combinations will be selected, and you can start the design. Alright, so this is the entire floor design that you can see that it's done. Similarly, if you want to design the slabs also, you can design the slabs. So it will ask you which floor that you need to select. Alright, so it will design all the slabs. It has already designed it. If you want to see that how it has been designed, so you can go here and instead of strip base, you can go to the finite element based, and you will get the reinforcement, which is direction 1. Direction 1 is always in X direction, direction 2 will be always in Y direction. So you will see that top reinforcement and bottom reinforcement. This is the bottom reinforcement. This you will get it in square per meter. Alright, so this is the design of the slabs, and here you will get the design of columns and beams in square. Now if you want to design the shear walls, you can go to the shear walls, and you can, let's say I'll just select all this and go to the shear wall designing. All the way there are so many checklists and so many things are there, actually, which you will do at the later stage. If you go to the, let's say, now I'll just show you these are the drawings that it will generate. These are the columns design it will generate. Beam design, this is the beam design. You can just scroll in and check that which rebar and all it has been used. You can see the shear walls that it has been generated, shear wall drawings and all. You can export the drawing from here to the CAD also. Alright, these are the longitudinal sections also. Now I would like to show you the cage views. So it will show you the cage view also. Alright, cage view for the columns, cage view, let's say, for the shear wall also, you can see that. Right. So I hope you are happy with this kind of design. Okay, and I'm sure that with this experience, actually, within just, I think, 1 day experience, you can solve this kind of problems very frequently, and very in a very short time. Uh, um, if you really want to have this kind of experience and all the related files, actually, please, give the email to, info@e-construct.in. We'll give you the all the support files and all the registration link, so that you will get this experience in a completely better way. You'll also get an assistance, actually, of 1 week to solve this project through online process. Alright, so I hope you enjoyed the session. Thank you very much. Bye bye.